Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. So, in this video, we are going to see about the nanomaterials. So, these nanomaterials are unlocking the future of the material science. So, you're all welcome to an exploration of the carbon nanotubes. So, what are these carbon nanotubes? They are the cylindrical nanostructures composed entirely of carbon atoms arranged in an hexagonal lattice with extraordinary properties that have made them some of the most promising material in the 21st century. It will be very fascinating to explore and know about the carbon nanotubes in detail. So, here, a revolutionary allotrope of carbon are the carbon nanotubes. Their unique atomic structure grants them unparalleled properties, driving innovation across the diverse industries and also promising to reshape a technological landscape. So, carbon nanotubes, the nanomaterials of the 21st century. So, we're going to explore on this. The carbon nanotubes, they have the remarkable properties. While seeing about the carbon nanotubes, the definition is already we have discussed. It is a cylindrical nanomaterials composed of sp2 hybridized carbon nanotubes. The structure is nothing. It's the rolled up single or multiple layers of graphene. There are broadly classified into two types. They are the single-walled carbon nanotubes and the multi-walled carbon nanotubes. The length can range from the nanometers to several centimeters. The carbon nanotubes has also the remarkable properties and they show a unique properties in the mechanical strength, electrical conductivity, thermal conductivity, stability, flexibility and surface areas. So this topic I'm going to explain on the DT based, that is design thinking framework. So let us take a real time problem. For example, you are solving a real world problem like you are having imagine lightweight durable bicycle frames breaking frequently under strenuous use. So this is the empathy part in it. So the cyclist, they use the bicycle for very speed approach and on also they seek the reliability. So a carbon fiber frame, though they are strong, it has still has some limitation. So the empathy part is you want a very still strong, still reliable carbon fiber frame. So how will you define this problem? To define what is the challenge, you have to develop a bicycle, that is the frame material that is much stronger so that lighter and also should be more fatigue resistance than the current carbon fiber composites. So the composite materials are the well-known strong materials that we come across, but still it needs more improvement to be more reliable and strong. So we have defined the problem clearly in this. And next the ideate part. So we have to brainstorm the possibilities. So who are the persons or the people that they are involved in this brainstorming? The scientists who are doing the research on the material. So the material scientists, then the athletes, they are the customers, okay, they are the users of this. And the manufacturers, they engineer the materials, okay. So we are brainstorming the different possibilities of these people. They recognize that carbon nanotubes could reinforce the composite materials, offering strength to weight ratio and flexibility over conventional carbon fiber. Okay, so you are adding, you are strengthening, you are improving the quality of the carbon materials by using carbon nanotubes. What is the prototype involved in it? Okay, the polymer composite reinforced with carbon nanotubes. The manufacturer, they assemble the frame, they integrating the carbon nanotubes at the nanoscale into the resin matrix to exploit their unique properties. So I have explained about this composites and resin matrix in another video. So these composite materials, when they have the nanoscale, carbon nanoscale materials into them, their property is enhanced or there is a reinforcement with the material. So this is the prototype. The next part is comes the empathy. Testing. So test in the laboratory and also in the field condition. So when you test it, we can see that the mechanical stress test can withstand a very high load, and the cyclist, when they use it and see, they can see it is lighter and more responsive. The long time fatigue testing is also noted. So carbon nanotube technology with athletic needs, leveraging empathy, and it also includes the multidisciplinary collaboration. So what are the remarkable properties of carbon nanotubes? So due to these remarkable properties, it is used in the latest technologies. That is, it possesses an extraordinary combination of electrical, mechanical, and thermal properties that surpass the conventional materials. So it's stronger than steel. It's not just stronger than steel, but it has some 100 times stronger than the steel at only 1 by 6th the weight. It has high current density. It's not, it just has a high current density. It values a very impressive. That is, it has 1,000 times greater than the copper. Thermal conductivity. So it has excellent thermal conductance along with the axis. That is, it's superior to diamond and copper. So additionally, their surface to volume ratio makes them ideal for the application requiring extensive interaction with the environment, such as sensors and catalysts. So this is the end of this session. We'll see the properties of this carbon nanotubes in the upcoming video. Thank you.